session tonight where we're looking for a positive integer solution. And I'll call this just z plus. All right, the natural numbers is normally taken to be 1, 2, 3, 4, 5, so on. Now what I'm going to do, y'all, is sketch a couple of graphs here to motivate a symmetry substitution. I'm just going to sketch the graph for this guy, both of them together here. So let's get busy doing that. All right, so y'all, this is just the real axis centered at 0. And everybody's familiar with the shape of the square root graph. They're just half of a parabola. And so we'll call this minus 81 right here, because that's where the beginning of the graph on the left would be. Okay, minus 81, substitute right here, gives you 0. And we all know that the graph of the square root function looks something like that. Okay, heads off in that direction, right? Half a parabola. Okay, now 111 is further over, so I'll try to, I've kind of run out of room here, but we'll say that 111 starts here, and it's 30 further away from the origin, which is a big part of what we're doing here. So this is 111. Okay. All right, and the graph just takes off in a similar way, right, like that. Now, one thing to notice here is that this point right here is 30 further away from the origin. 30 further away. 111 is 30 units larger in magnitude than 81, okay? So again, remember, this is the x-axis right here. Now let's try this idea. Right underneath it, I'm going to make up another letter here. Okay, and what I'm going to do is call this the u-axis. The u-axis. Now notice that if we just push him to the left 15 units, we get, and I'm not really making a big attempt to scale this, we would get minus 96, right? Minus 96. And the same thing right here, if we push him 15 to the left, we get plus 96. So I guess it kind of stayed to scale. So this is plus 96. All right. So this is symmetry. We're talking about the origin on just the real number line. And you can think of this, if you want to, I guess, as the u minus, I don't think that's a stretch, the u minus 15 axis. Now, actually, maybe that's, it may be better to write it like this. Let me that's probably not quite accurate to talk about it like that. We can think of this as the u equals to x minus 15, I guess is okay. Right? Because that's all it is subtracting 15 from this x coordinates and from this x corner to this x point also. Okay, so we can call this the u is equal to x minus 15 axis if you want. Now what that does is it motivates this substitution right here, okay? Because you can see it's just you're gonna get cancellations. Now, that's not crystal clear at this point, but let's just check out what happens with this substitution. Okay, now, and this is what I just told you a moment ago. You end up with u plus 96 and u minus 96. If you think about it just as points on the u-axis, okay? Now, and the rest of it's fairly straightforward. This equation, this original problem that we're trying to solve becomes u plus 96 radical plus u minus 96 radical, okay, equals 32, all right? And then normal sorts of things happen right here. We bring one to the other side and square away. I chose to isolate u plus 96, the square root of u plus 96, I should be saying. And folks, when you square both sides, you end up with all this stuff here. And I won't, you can verify that I didn't make any mistakes here. Now notice that due to the symmetry, I guess the u's cancel. You see how the u's go away? And so we get this nice circumstance right here, okay? Now, something nice happens here on the very next line, if you divide all of this stuff by 32, if you divide this by 32, you just, 32 squared divided by 32 is 32, right? Righty? Now, right here, if you divide 96 by 32, you get 3, and 2 times 3 is 6, right? So you see, that's where this 26 minus 2 came from, okay? Again, dividing everything inside by 32, 32 squared divided by 32 is 32. This would become 2 times 3, which is 6, and then minus 64 divided by 32 is 2, which is what you see right here, okay? Now, if you divide this by 2 and square, you end up with this statement here. Again, if you divide both sides by 2, you would get the square root of u minus 96 is equal to 13. That's where this 169 comes from, which is 13 squared. Okay. Okay, so we're making quite a bit of progress here, folks. Now we know that just the arithmetic leads to u is equal to 265. But notice right here, if u is equal to 265, right here, that would imply, that implies that x is equal to 280, right? .280 minus 15 is 265. Okay. Now I'm going to circle that as the answer, but we can check. So let's come down here. This is the original equation. Notice that if you substitute 280 right here, you would get the square root of 361. All right, and then if you substitute 280 in for x right here, you get 280 minus 111, which is 169. Okay, folks, and this is equal to, I didn't need to do that. This is equal to 19 plus 13. That's 19. 19 squared is 361. Okay, plus 13. 13 squared is 169. Okay, and that does equal to 32, so it does check. Equals 3, 2. Folks. So that is the answer, folks. And again, I hope you like that. I really think drawing these two axes, you know, and seeing just how the shifting leads to this natural substitution. But this natural substitution, when you put it in and do all the arithmetic, a lot of nice things happen. You end up with nice numbers. The u's actually cancel, and you can do all the calculations without even knowing what 32 squared is, you know. So anyway, I thought it worked out rather nicely, and I'm not quite sure. I think it works, the arithmetic's a little more burdensome, or the algebra's a little more onerous, you know, if you just stick to it directly without using the substitution. But in any event, that's the answer. 280 is the answer, and I hope you enjoyed it.